For this lesson on angle pair relationships and converse proofs, it's very essential that you know your angle pair relationships. So what I want you to do right now is stop the video and do this first page where you're making sure that you understand how they're related. So for example, when we say how are angle 1 and 2 related, you're going to look at this and recognize that these two are a linear pair. When I ask you how angle 1 and 5 are related, you're going to tell me that they are corresponding angles. And finish up this page that way. We will check this in class and then resume the video. Okay, so we're going to prove some of the theorems in this section, and then we're going to leave some of them for you to try on your own. Part of this will also be leaving for class, so pay close attention to so that you know which parts you're supposed to do. So the first part here is based on our corresponding angles postulate, which tells us that if a pair of corresponding angles formed by two lines cut by a transversal is congruent, then the two lines will be parallel. So if I look at this this figure right here, and we want to make K parallel to L, then which pair of corresponding angles could I use? Well, there's several possibilities. Angles 1 and 5 are corresponding angles. So I could set up angle 1 congruent to angle 5. Well, and we would need them congruent, so let's use the congruent statement here. I would need that to be true. That would be one option. There are 4 other options, and I want you to write those out. So you should have a total of 4 when you're finished. Okay, so let's look at the one below this. The converse is going to go the opposite direction. In this case, we know that the two lines are parallel, and then the converse postulate proves that the corresponding angles are congruent. So, if I tell you that these two lines are parallel, then I can make all sorts of conclusions on my corresponding angles. So, angle 1 corresponds with angle 5, which means angle 1 is congruent to angle 5. Again, I want you to do these last 3 as trimedes. Stop the video and then resume it when you've completed it. Okay, so in the next part, it kind of jumps over from this page into the next, but what we're told here is that M is parallel to N, and they want us to find the value of X. Okay, well, if those two are parallel, then I know that corresponding angles are congruent, and I know that these two are corresponding angles. So that means I can set 5x minus 10 equal to 2x plus 2, and I can solve to find the value of x. Stop the video right now, and I want you to go through and find the value of x. Hopefully you found that the answer was 4. If not, look through the steps here and find your mistake. Okay, this next section I do not want you to do right now. There's some very specific things that we want to point out and some later theorems that are going to make this easier. So we want you to leave this for class. Don't write all over it, but we are going to leave this for class next time, including the trimeme. We don't want you to do the trimeme on your own right now. So let's move on and look at the first proof that we are going to do. The alternate interior angles theorem states that if two lines in a transversal form congruent alternate interior angles, then the two lines are parallel. So let's look at how we would prove this. Okay, as we know, the first step in any proof is to know what we're being asked to do. So in this case, we are told that two lines form congruent alternate interior angles. So we're going to take our given to be that angle 3 is congruent to angle 6, and what we are asked to prove is that the lines are parallel. So we're going to prove that K is parallel to L. So I want you to do your first step. Your first step is always your given, so we know that this is going to be that angle 3 is congruent to angle 6, and our reason for that is that it is given. After this, what we need to do is look for things that we can do to use our corresponding angles theorems, because that's the only one that we own at this point. So based on that, I need to link angles 3 and 6 using a pair of corresponding angles. Well, 3 corresponds with 8. So if I can look for the relationship between 6 and 8, that can help me get there. Well, we know that 6 and 8 are vertical angles. So I can say that angle 6 is congruent to angle 8 because of my vertical angles theorem. Well, now I have 3 congruent to 6 and 6 congruent to 8, which means I can draw the conclusion that angle 3 is congruent to angle 8 because of the transitive property. Now that I have angle 3 congruent to angle 8, which is a pair of corresponding angles, I can state that the two lines that I'm looking for are parallel because of my corresponding angles theorem. And that completes our proof. All right, so now let's go on and look at the next proof. Now we have two parallel lines cut by a transversal, and we're supposed to prove that the alternate interior angles are congruent. This time we have to prove both pairs, or we've only proven that one particular pair is congruent. So let's set up our proof. Okay, so what we have given is that the two lines are parallel, so K is parallel to L, and we're supposed to prove our alternate interiors. So we need to prove angle 3 congruent to angle 6 and angle 4 congruent to angle 5. So our first step, again, always is our given. So now let's look at what we know. Well, we know that because the lines are parallel, we know that all of our corresponding angles are congruent. So let's choose a couple pairs of those to help us out. If angle 3 is congruent to angle 8 and angle 4 is congruent to angle 7, that's going to help us get where we need to go because I'm using most of the angles that I need. The only angles I still need to bring in are 5 and 6. So let's look for relationships that involve 5 and 6. Well, if I notice right here, angle 5 and 7 are vertical angles, and so are angles 6 and 8. So our next step is going to be to make use of that theorem, our vertical angles theorem, to make that statement. Well, once I know that 3 is congruent to 8 and 8 is congruent to 6, then I can use my transitive property to get 3 congruent to 6. I can use that same logic to get 4 congruent to 5. That's what I was asked to prove, so my proof is now complete. Okay, so now let's go on and look at what happens when we have specific angle measures in there. We can still go through the same procedures. This time we'll just have a little bit of substitution, putting in that angle measure where it applies. So let's start with our setup. Okay, so we need to link angles 1 and 7. So to do this, we can make the link from 1 to 4 and 5 to 7. We know that those two pairs are congruent. We also know, because of alternate interior, that these, not alternate interior, we want to go from 1 to 5. Corresponding is going to get me these two to be congruent. Once I know that, then it's just a quick jump to getting what we need. So let's take a look here and see what we've got. Okay, after we've stated our given, we're going to use the vertical angles theorem to link angles 1 and 4 and angles 7 and 5. Once I have those linked, then I just need to get from one of those pairs to the other. There are several different ways you can do this. You can link 4 and 5, or you can do what I've done here, which is linking 1 and 5. I use the converse of the corresponding angles theorem to do this. Because I know my lines are parallel. Once I have angle 1 congruent to angle 5, then I can simply use my transitive property to link angles 7 and angle 1, because I can pull those in through that way. Once I know that, then I do, because right now I'm still in congruence and I need to get into angle measure, so I can make the jump into angle measure. Once I do that, I can just do a quick substitution. Angle 1 is 25 degrees, and there is my proof. All right, let's look at the next one. Our next theorem is the converse of the consecutive interior angles theorem. This states that if two parallel lines are cut by a transversal, so that's our given, then consecutive interior angles are supplementary. Our consecutive interior would be 3 and 5 and 4 and 6. So to get there, what we want to do is use the concept of a linear pair. Our linear pairs that are going to help us out here are 1 and 3 and 2 and 4. Once I use those, then I can make the jump that angle 1 is congruent to 5 and 2 is congruent to 6 using the converse of my corresponding angles postulate, since I know that the lines are parallel. Since I need to get to a specific angle measure, I need to use the definition of congruence to jump from congruent angles to angles with equal measure. And then we can just do substitution. I'm substituting angle 5 for angle 1, and I'm substituting angle 6 for angle 2. And that gives me two statements that show that angle 5 and 3 are supplementary and angle 4 and 6 are supplementary by the definition of supplementary angles. Okay, that's the last proof that we're going to do together for right now. But you're going to go do a few of these remaining ones as trimies. Your teacher will check these in class and expect them to be complete. And then we're going to leave some to do in class. So you'll need to page through the next few pages with me so you know which ones you need to do and which ones you can leave for class. So let's look at our next one is the converse of the alternate interior angles theorem. This is a trimie. I want you to do this proof. Look back on the ones that we did, and you're going to find one very similar to that. The next page has got your converse of your consecutive exterior angle theorem, and this one we're going to leave for class. So you do not need to do this one. Don't write on it because you're going to do it in class, but for right now you can hold off on that one. The one after that is our consecutive interior angles theorem, and this is one that I want you to try. So this one's going to be a trimie. After that, we've got one that we're going to leave for class. So again, don't write on that. We'll leave that one in for class. And then our final proof in this section is a trimie again. If you want to page back through the ones that you have to try, I'm going to go ahead and give you the given and proofs that follow directly from the statement so that you know what you should be giving and proving. Okay, this is back on page 62 with the first one that you have to try. My hypothesis tells me I have parallel lines, so my given needs to be that K is parallel to L. My conclusion is what I'm trying to prove. It says alternate exterior angles are congruent. So my alternate exterior angles would be angle 1 and would need to be congruent to angle 7, and angle 2 would need to be congruent to angle 8. Now skip ahead to the next one that you needed to try, which is not this page but the following one. So now you should be on page 64. And we want to look at this the same way. Okay, they form supplementary consecutive interior angles. Okay, so I'm looking for a pair that are consecutive interior, and I have to say that they're supplementary. So I'm going to say angle 3 and angle 5 are supplementary, which means you're going to have to get them equal to, adding up to equal 180. And the other piece is that that's all I need. Yep, that's my given here. What I'm trying to prove here would be that the lines are parallel. The last one, I want you to practice reading through the theorem that they give you and coming up with your given and proof in the same manner. Okay, this is the end of the video. Make sure you finish all of the trimies in the notes, and we'll see you in class. Don't forget about your MML homework.